So we're looking at 10.1 today, rectangular coordinate system. Getting into graphing. This right here is just a note for myself. I'm about to switch screens to go to some notes that I've already written. But the rectangular coordinate system is where we're getting to today. Yep, thank you for that. Appreciate that. Classmate gave us a reminder that you have to send your scratch work for all of your tests. You know, when you submit your test, you want to send in that scratch work. Appreciate that. Good do. All right. So your Cartesian coordinate plane. For 1 second. All right. So our Cartesian coordinate plane, we have an x-axis and our y-axis. Where they intersect is our origin. X-axis is a horizontal axis. Y-axis is our vertical axis. They intersect at the origin, 0, 0. Somebody said they remember this. Yep, yep. To the right of your origin is positive values. To the left of your origin, negative values. Above your origin, positive. Below your origin, negative. Splits up into 4 quadrants going counterclockwise. Quadrant 1, 2, 3, and 4. To get into quadrant 1, you make 2 positive moves. Quadrant 2, negative move, then a positive move. Quadrant 3, 2 negative moves. Then quadrant 4, positive, and then a negative move. All right. We'll be graphing in this coordinate plane by ordered pairs, called ordered pairs because the order matters. Your first move is always your X or your horizontal move, and it's your vertical move, which is Y. You can think about X comes before Y in the alphabet. You walk, then you go in that, walk to the elevator, go down, you run, then jump. Whichever way you want to look at it. It's always your horizontal move first, then your vertical move up or down. Give y'all a chance to finish copying that before we scroll up. All right, you good. All right, so let's erase some of this stuff so we can walk through it. Make sure we're good. All right, so we got about 6 points we want to graph just to make sure we're good with graphing. So we looking at 2, 5. You always start at your origin first. Always start at your origin. And we go to the right 2 because it's a positive 2 and then up 5, which is positive 5. So 2, 5 will be right here, and that is quadrant 1. Second point, start at your origin again, go to the left 1, down 3 because both of those are negative. And that's quadrant 3. Next one, start at your origin once again, go to the left 4, then up 2 because the 2 is positive. So I'll put this in quadrant 2. Then 1, negative 5, I go to the right 1, positive 1, and then down 5, which is a negative 5. That puts us in quadrant 4. So before we look at the last 2 points, questions on those first 4. All right. So looking at those next two, for 3, 0, I would go to the right 3, but then I wouldn't move up or down for y because 0. So that puts us on the x-axis. That's not actually in the quadrant, or in a quadrant, puts us on the x-axis. And then for that last one, you go back to your origin. You don't move left or right for your x value because it's 0, but you go up 3. And that's sitting on the y-axis. All right, questions? Any questions? All right, scroll up. Everybody good? All right. So solutions. We're talking about solutions of a function that has two variables, x and y. For example, ordered pair. That should be an ordered pair. An ordered pair is a solution of an equation if the equation is true after the ordered pair is plugged into the equation. So for an example, we have this 4x minus 3y equal to -2. And what they would want you to do, they'll give you an ordered pair and want you to determine whether that ordered pair is the solution of the equation given. All right. So we take that 1, 2 and plug it in respectively for the variables that it represents. We have 1 for x, 2 for y. Remember, that's always going to be your order. X comes first, then y. So we plug 1 in here, 2 in here for y. 4 times 1 minus 3 times 2. That's 4 minus 6. That's -2 equal to -2. So since that's a true statement, that is a solution of this equation. And so there are infinitely many solutions to a linear equation. When you go to graph that line, every point that is on that line is a solution for that equation. So this point 1, 2 would actually be a point on this graph if we were to graph it. All right. Any problems? All right, so let's try it one more time. So this time they give us the equation y equal to 3x minus 5. Then they give us two ordered pairs to try. So we have 2, 3, and 3, 4. So over on the left, I plug in 2, 3. So that's 2 for x, 3 for y. So that's why we have 3 equal to 3 times 2 minus 5. 3 times 2 is 6. 6 minus 5 is 1. So 3 is not equal to 1. So that's not a solution. All right. And then the next one over here to the right, I plugged in 3, 4. And that one ended up working out for us. 3 times 3 is 9. 9 minus 5 is 4. And so that means it is a solution. 4 equal to 4. All right, questions? Any questions? All right, scrolling up. All right. So when it comes to graphing linear equations, the equations that gives us a straight line, we have 3 different ways we can do so. XY chart, which is going to be in section 10.1, and they talk about it in 10.2 again. And let me make sure I did see that correct. Yep, yep. Then 10.2, you graph using your intercepts, and also you can graph using your slopes. So we're just going to do one of those today, but 10.2 covers the other two. All right, so let's look at the first one. I'm gonna erase this stuff so we can walk through it. All right, so let's say we want to graph y equal to 2x plus 1. So what you would do is choose x values. Notice I said you choose, so I chose -1, 0, and 1, but you would choose the x values to plug in. Remember, whatever x values you choose, it's completely up to you, but remember that you have to graph it. So if you're talking about going to 150 and then 1 million, then that's fine, but just remember you have to graph it, and you'll see why it doesn't matter in a second. But it doesn't matter as long as you correctly calculate it and you have the ability to graph. So like I said, I choose something easy, -1, 0, and 1. Then from there, you want to plug in x to find the corresponding y value. So in other words, when x is -1, what is y? So that's 2 times -1 plus 1. 2 times -1 is -2 plus 1, and that is -1. So it just so happens that when x is -1, y is -1. Of course, that doesn't always occur. Here, 2 times 0 plus 1. 2 times 0 is 0 plus 1 is 1. So when x is 0, y is 1. Then do the same thing for +1. 2 times 1 is 2 plus 1 is 3. So those are our 3 points. So before we go and graph them, any questions? Once again, don't forget, you choose the x values you want to graph. Doesn't matter. As long as you calculate correctly, you will get the proper line. Then from there, you plug into the equation, find the corresponding y value. All right. So now you graph those 3 points. -1, -1. So I go to the left one. Always go back to your origin. Start at your origin, excuse me. Go to the left one, down 1. So that's this point down here. 0. So I go nowhere for x, but I go up 1. So that's the point right here. And then go to the right one, up 3. And that's this point right here. Connect your dots, and you have your line. Now, so like I said, it doesn't matter what value you choose. You still get the same line. So in other words, let's say if I use +20, 20 would be somewhere over here, but it will give me a y value up here that will connect to this line. And I still will get the same line. Same thing as if I chose something like -100. -100 would be way over there to the left, but then it will give me a value that's down here that will still connect to that line. That will still give me the same slanted line. So it just remember, you got to be able to graph something like that. So it's always good to use smaller values that you don't mind calculating and make sure that it stay on the same grid. right. Any questions before we look at another one? All right. So I'm gonna erase this stuff just so we can see what the problem is without all my writing. I'll put it back up in a second though. All right. So equation is y equal to -3/5 x plus 2. So we don't want to have to graph decimals or fractions if we don't have to, right? So what we want to do is plug in values, because remember, we get to choose our x. We want to plug in values for x that would produce a solid integer, a regular number, not a decimal, not a fraction. So what we're going to do is choose values that will be multiples of our denominator. All right. So what I mean by that is that if you look at your denominator, it is a 5. So I would choose multiples of 5. So we're talking about, 5, 10, 15, 20, 25, 30, something that the 5 can divide into evenly. Same thing as if that was 11 down bottom. If that was 3 over 11, I would choose values that 11 could divide into. If that was a 7, I would choose values that 7 can divide into. All right. So you want multiples of the denominators. You want numbers that the denominator can divide into evenly. So what I chose was -5, 0, and 5. That keeps in line with what I was choosing, -1, 0, and 1. Once again, you don't have to choose those values. You can do 5, 10, 15 if you want to. But you want to choose values that the 5 can divide into evenly. So now when we look at over here, when we go to plug in -5, -3/5 times -5, all I did was multiply across. When we talk about fractions, just multiply across. So that -3 times -5 is 15. 15 divided by 5 is going to be 3. 3 plus 2 is 5. So when you plug in -5, you get out +5. All right. Plug in 0. 0 is always a good number to use because anything times 0 is 0. 3/5 times 0 is 0 plus 2. That'll be 2. So when x is 0, y is 2. All right. And then plug in at +5. So that'll be -15 over 5. -3 plus 2 is -1. So when you plug in +5, when x is +5, y is -1. Questions before we look at the graph? All right, so going back to the chart, let me put this one right here. Leave this one right. Oh, -1. Make sure I got my numbers right. I got a 5, 2, and -1. All right. So when you go to graph, go to the left 5, up 5. That's this value right here. 0, 2. So you go nowhere for left. Don't go to the left or right for x, but then you go up 2. So that's this point right here. And then to the right 5, down 1 is right here. Connect your dots, and that is your line. All right. Questions? Any questions? All right, we're not doing this stuff today. Got one last type of thing to talk about. So questions before I go to the next screen. All right. So we're going to talk about functions real quick. Make sure you're okay if they were to ask you certain questions about functions. So looking at the definition of a relation is just any set of ordered pairs. So the example we have here is 1, 2, 3, 4, and 5, 6. All right. The domain is going to be the set of all the first components of the ordered pairs. So when I look at 1, 2, 3, 4, 5, 6, 1, 3, 5 would be your domain, just the first component of each ordered pair. Your range is a set of second components of the ordered pairs. So we're looking at 2, 4, and 6. Make sure everybody's good with the range. Next, we're looking at a comparison to the domain and range, just, first component versus second component, vice versa, that type of thing in a second. Just want to make sure everybody got the range down. All right, we good? Okay. So comparing the two, straight comparison between the two, domain and range. Domain is your first component, where range is your second component. That means your domain will be your x variables, when your range will be your y variables. Domain is your input, range is your output. Domain is also your independent variable, and your range is your dependent variable. Also, your domain is your horizontal axis, when your range would be your vertical axis. All right, scrolling up. All right, so here, definition of a function, just in case they ask you about it in the web assignment. So a function is a relation in which the elements from the domain corresponds to exactly one element in the range. Looking at your homework, I didn't see one where they actually ask you to determine whether it's a function or not. So we don't have to worry about it right now. If you see it, then feel free to shoot that to me or something, and then we'll talk about it in class. But I don't see it in the homework, so you shouldn't see that. But you should know what it is because they may reference the function on the term function. So once again, a function is a relation in which the elements from the domain corresponds to exactly one element in the range. All right. Anybody still holding on to this before we go finish it off? All right. All right, so function notation. This leads us to get ready to close out the section. So y is equal to f of x. So what they're saying here is that if I have the function y equal to 2x plus 1, then I can interchange f of x with y and still be saying the same thing. And they expect you to know, that that is the case. So if I have y equal to 2x plus 1, the same thing as f of x equal to 2x plus 1, because y and f of x are interchangeable. So what that means is if, right now I'm not looking at this part, but let's say if I just had f of 5, it didn't even say find f of 5, but it says f of 5. If I want to know f of 5, because I know what f of x is, I can find that. So all that means is that I'm going to take 5 and plug it into my function wherever I see x. So that's what we're looking at right here. If it says find f of 5, all that means is I'm going to plug 5 into my function. So that'll be 2 times 5 plus 1. 2 times 5 is 10, of course, plus 1, that'll be 11. Also in your notation, if you have f of 5 is equal to 11, that also means that your ordered pair is 5, 11. You put in 5 or substitute in 5 and got out 11. All right, questions on that before we go any further? All right, scrolling up, we have a mini word problem, but it's still focusing on this concept of function notation. You'll see why in a second. It says the surface area of a cube is given by, and they give us this function right here, SA of S. And I felt like they could have notated it better, but that's what it gave you. So SA of S is equal to 6S squared. So these are S's. 6S squared is your function, where S is the length of one side of the cube. Find the surface area of the cube that has a side length of 10 centimeters. So I'll let you write that down before we do that. All right, so it said the surface, but the side of the length of the length of the side that we have is 10 centimeters. So that's why we have right here, S is equal to 10. And all that means is that you need to take 10 and plug it in to the function for S. And that's what we did there. So 6 times 10 squared. 10 squared is 100. 6 times 100 is 600. And that's surface area, so that would be centimeters squared. All right. Anybody hold on to that before we look at the last one? All right. So the last one was you just evaluate. They give us this function, g of t, which is t squared, 2t squared minus 3t plus 1. They want us to evaluate it when t is equal to -2. Once again, all that means that we're going to plug in the value that they give us for the variable in our function. So you plug in -2 for t. That's t times -2 squared minus 3 times -2 plus 1. All right, -2 squared is +4. -3 times -2 is a +6. 2 times 4 is 8. 8 plus 6 plus 7, I would say plus 7 plus 1 is going to be 15. And that's it. Questions? Any questions? All right, so before we close out today, any general questions or concerns? Anybody? Everybody good? Everybody straight? All right. So, well, that's it for today. Knock the stuff out. Next class, we'll get started or get back into chapter 10, looking at section 10.2, and then go from there. So you guys have a good one. Be safe. Have a great weekend, and I'll see you on Tuesday.
Thank you.
All right, thank you. Somebody said last order pair, -2, 15. Yep, that would be the order pair. Yes, that would be -2, 15. Yep. All right, not a problem. All right, you guys have a good one. Take care.